Hey, good afternoon, everyone. I'm Changsha Ma. I'm an AI ML specialist solutions architect. I think, okay, the gentleman who asked the question, how we are customer obsessed, right? So, we solutions architect help our customers adopt, those AI ML solutions on AWS. And we event on behalf of our customers based on their feedback, right? So if they have used our services and they are expecting some amazing feature, which makes their life hard, and we submit the product feature request on their behalf and add a customer impact, and then our service team will evaluate and then add those features on behalf of our customers. That's why today I'm going to introduce SageMaker. It is the most comprehensive AI ML platform on the cloud. And in particular, I'm going to introduce SageMaker's role in MLOps, machine learning operations. All right, so let's start. Okay, let me move this screen a little bit. Okay, so now it's better. So let's start with talking about this machine learning workflow, because before we jump to the MLOps, because the goal of MLOps is to operationalize this machine learning workflow and make the workflow easier for data scientists and MLOps engineers. By the way, any data scientists, MLOps engineers in the room? Okay, nice. What is your role?
I'm mostly the machine learning.
Machine learning.
I'm a student at Duke University.
Okay, good to know you. Okay, all right. So and we have a data scientist, MLOps engineer that I know years of. Okay, so this is the machine learning workflow. So on the high level, so it has 3 steps, right? So you start with the data preparation because data is the food of your machine learning models. And then you do the model training and model tuning, and the story doesn't end by then. So you have a model, you deploy a model in production, and you need to keep monitoring that. So let's first take a look at this data preparation. So you will need to first ingest the data from multiple data sources, right? So and then you may integrate the data from a variety of sources and do some analysis and feature engineering. And those feature engineering work can help your machine learning algorithm better pick the patterns in your data. Right. So and after you've got a good set of features, so you will start choosing the algorithm. What it is if it's a tabular data, so I may consider XGBoost or LightGBM or whatever algorithms you need to choose from. And then you will train the model using the chosen algorithm on your feature set. So sometimes the feature size can be large, right? So and you may need a powerful machine, or you may need a distributed training. So the goal is to train a model on your data at scale. And then you need to evaluate your model's performance and measure whether the business goal has been met, right? So if my goal of this malware detection model, for example, is 90% accuracy, so is my model good enough? If it's not good enough, then I may probably need to reiterate, right? So maybe my data is not enough. I need to collect more data. Maybe my features are not powerful enough, so I need to reselect my features. So you will go through this cycle until you eventually meet the business metric. And now, okay, you can deploy the model in production. But so we have data scientists, we have machine learning expert. So that the model, after the model is deployed, it may not perform as well as its performance in the training stage. Why is that? Because the data in production often is different, not necessarily the same, as the training data, right? So that's why you need to monitor your model's performance, because the data performance, it degrades, right? So when it degrades, so you may need to consider, okay, maybe I needed to retrain my model. Okay, so maybe I wanted to make my model more robust, or maybe I needed to go back to the feature engineering stage to make my feature more robust, right? So anyhow, you will see. So this is an iterative process. So think about it. If we don't have MLOps, data scientists need to, work on each block. So how painful data scientist job would be? It would be the most sexy job in the world, right? So, okay, so glad that, we have MLOps. So now let's talk about the stages of MLOps. So the first stage, or the initial stage of MLOps adoption is there is no MLOps really, right? So we have data scientists who are really passionate about model training, building the models. And then we have data engineers, or the MLOps engineers, so who are really good at package your model and deploy it in your production environment. And in the real-time inference, real-time prediction scenario, for example, they need to make sure your model's latency is good, right? So, and if you wanted to monitor, and okay, so I have a make sure your data is captured in production so that you have something to evaluate the model performance. But all of those are, involves a lot of manual steps. Okay, so I experienced the same stage. So when I worked as a data scientist, so initially it was okay because we only have a couple of machine learning models, not a lot of use cases, right? So however, when the number of use cases increased, so we feel the pain. Okay, in this stage, so we are, considering how to automate the process and reduce the manual handoffs between data scientists and MLOps engineers, right? So the simplest, example could be, so as long as I have a model, I have a way that, I don't have to ask MLOps engineer, can you deploy this for me, right? So after I trained it, I validated it, I wanted to deploy it immediately, of course, with some, quality control, right? So, and then in the third stage, so you are looking for more, you are considering to add a quality management of the whole process. So automation is not meeting your goal anymore. You are considering, okay, so how to make the process easier, and I'm able to track the model versions for the quality control. And you're considering the CI/CD, the continuous integration, continuous development process, right? So, and this stage we call it a reliable stage. And the last stage of MLOps maturity is the scalable stage. It's really, in this stage, so the AI/ML workloads, is tremendous, is very popular among the organization. And you are thinking, how those different models can be reused, how these different models can be shared, and how those features can be shared across different teams, right? So, and in this last stage, you consider, scalability of MLOps. So no matter which stage you are at, you can consider to utilize a SageMaker to help make your MLOps journey easier. So which SageMaker? So by the way, anyone have tried SageMaker before? Only one? Okay, try it. if you have an AWS account, so I encourage you to try SageMaker today. If you don't have an AWS account, I encourage you to register, free trial account and try SageMaker. So I was a data scientist as introduced. When I first joined the AWS, started to learn SageMaker, I was like, I really wish I have known SageMaker earlier because it really makes my data scientist life much easier. Okay, coming back to this SageMaker for MLOps topic, right? So with the SageMaker, so you can automate your ML machine learning workflows to scale the model deployment process. And you are also able to build the CI/CD pipelines for machine learning to accelerate the model deployment. So for both of these two features, I later will show you a demo, okay, so that you have a more intuitive understanding of how really does it work, right? And with SageMaker, so you can catalog the model versions, the metadata, the model metrics, right? So that you can trace your model deployment stages. And with the SageMaker, is because it logs every step of your workflow, so it's easy to track the lineage for troubleshooting purpose. And also, with SageMaker model monitor feature, so you are able to maintain the accuracy of the predictions even after your machine learning models are deployed. Okay, and lastly, but not leastly, is a very, very important feature, security, right? So with the SageMaker, so you can enhance the governance and the security to for your machine learning models to meet the compliance. All right, so we talked about those features high levelly, right? So this is a high level overview of the SageMaker features, SageMaker MLOps components in particular. So basically there are three key components. So the first one, this orange box, is the SageMaker pipelines. Okay, so with the SageMaker pipelines, you can automate so each step of your machine learning workflow. So for example, so here you see so the data processing and then model training and the model evaluation, and then register your model after it meets the business metric. So, and then the second component of SageMaker MLOps is model registry, right? So this is a central place to store your machine learning models, right? So we mentioned earlier, so machine learning workflow is an iterative process, right? So you may, for the same business use case, you may iterate and build multiple versions of models, right? So these different versions of models may serve with different performance on different data sets. That's why you need to track the model versions, and SageMaker model registry serves for that purpose. And the last component, so the third component is SageMaker projects. Okay, so SageMaker projects, it has some pre-built, pre-configured MLOps project templates. So you can also customize your own template using CloudFormation or Terraform, right? So that you can deploy this machine learning development and deployment environment with the template through a single click. And later I'm going to demo you how that works. All right, so before we jump to the demo, let's explain a little bit more on each component, right? So the first component is SageMaker pipelines. So here is a model building workflow. Okay, so it starts with the data processing, and you see that the raw data resides on S3 bucket. So S3 bucket is a simple storage service on AWS. So it is very affordable and scalable storage service. So as ideal if you have a large amount of data to store, right? And this SageMaker data processing step, so it can read the raw data from S3 bucket, and after processing, it will store the processed data into another bucket, so that in the model training stage, so the model knows where to retrieve the data from and build the model. So once the model has been built, it is stored in another S3 bucket. And so that the model evaluation stage can retrieve this model and the associated testing data, and to measure whether the model accuracy has met your goal. And if yes, you register the machine learning model, right? So at the first glance, so you may wonder why I need so many S3 buckets, right? So because in the past, in a single notebook environment, so in a silo machine, I don't have to put my upload my data and then download my data back, right? So then why we decouple, these steps in this way? So, right. So the reason is that, so for machine learning, at each step, so the data processing and the model training, they require different types of packages. They require different types of computer resources, right? So for a model training task, you might need a large enough instance with multiple CPU, enough memory to execute the task. But for data processing, so it might be not the case, right? So maybe it's more memory sensitive, but less computer resources sensitive, right? So on and so forth. You get the idea. So there is a need, to decouple these different, steps. And that's why we insert, we put this S3 bucket to save your result at each step, so that you can focus on those different steps, and also helps you to debug when a certain step fails, right? So that you don't have to start over, right? Okay, so that's the idea. And it's really intuitive to use SageMaker pipeline. So 3 steps. So first, so you create the steps of your machine learning workflow, such as data pre-processing, model building, and evaluation. And then you define the pipeline. This pipeline is just the chains that's steps. It defines which steps goes first, and then second, and then third, so on and so forth. And then you can start the pipeline to execute from the beginning of the workflow to the end of the workflow. All right, so SageMaker model registry. All right, so how does it work? So it is organized in a hierarchy. So in model registry, you will find some, model group. Okay, so what does a model group mean? So you can treat it as business use case related or project related, right? So if I wanted to detect a malware, if I want to predict a housing price, so I may put my models in 2 different model groups, right? So that it's more organizable. It's almost like a file directory, right? So when you need to retrieve a version of a model, you need to specify the group first, and then specify which version you are retrieving. All right, so it works as simple like 2 steps. So first, you create your model group, right? So give it a name, create this model group, and when you have a model, so you turn a model and you register, your model version into this specific model groups. And then later you can retrieve your model by specifying the model group and the versions. Last, okay, SageMaker projects. Okay, so how does SageMaker projects works? Okay, all right, so as a data scientist or ML expert, right? So we all know when we develop a model, we need a lot of libraries. Okay, so and I need a machine. I need the machine be configured with these libraries, right? So this is the so-called development environment, right? So and if think about if a data scientist, whenever they create, so they need to develop a model for a use case, they need to do the configuration. So it's a lot of work, right? So but think about this. So what about I can set up your development environment by a click, right? So using CloudFormation template or Terraform template, you can do that. So on AWS for SageMaker projects, we store the CloudFormation or Terraform templates in service catalog, which is a central place to manage your infra as code templates. And then when data scientists enter the SageMaker environment, so they choose which template to use. And then they can choose that template, and by selecting that template, your building environment or deployment environment has been set up. And then you can, data scientists can focus on, okay, maybe I can change my hyperparameter. Maybe I wanted to change my, feature engineering code. Then you can focus on your data science job. So don't have to worry about those environment setup thing. So, okay, so that's only the first thing. So the second thing is, so we mentioned, so after you have, build your model, you wanted to deploy it. How does it happen? Okay, so, and this template, it can define the process of, once model has been trained, once model has been evaluated, then what endpoint to be deployed for this model. So you can, configure every step using this template, and then launch this, SageMaker projects, and focus on your model building process, and don't have to worry about how to bring your trained model into production. All right. So this is a list of features, right? So as mentioned earlier, so SageMaker provides you some built-in project templates. So with this templates, so you can have different options, right? So if you are in the model building stage, so you can choose a template which can help you build your model and train your model, and in the production stage, so you may choose a template which can do model building, model training, and then model deployment. And you may also want to add a model monitoring. So if your data in production changes over the time, right? So apart from those built-in project templates, so which is really a good starting point for a variety of machine learning development use cases, you can also choose your custom project templates and save your templates in service catalog, and then those templates are visible in SageMaker, so that when data scientists deploy a model, so they have the template to choose from. All right. So now I'm showing you MLOps architecture example. Okay. So this red box is one AWS account. Okay, so let's call it a development account. So this is a development account for data scientists or ML ops or ML engineer to use. Okay, so they are building models in this account. So here you see. So in the green box is the Amazon SageMaker Studio, which is web interface IDE for AML. So they can develop in SageMaker Studio using notebook and ingesting the data sources from S3 we mentioned earlier, or EMR and so on and so forth. And then they can utilize those MLOps CI/CD components like AWS code commit and to trigger the SageMaker pipeline. So the SageMaker pipeline, as we mentioned earlier, right? So it is a workflow to chain each step of your machine learning workflow. So, and once this, SageMaker pipeline has been executed, so the model will be registered in SageMaker model registry. So this is how you see it, right? Okay. And now you will see, okay, sorry. So now we'll see there is a Amazon event bridge component. So this Amazon event bridge is an event bus. Okay, so you can just set up some rules, to schedule the triggering of this SageMaker pipelines. So you can also configure this, event bridge when to trigger this SageMaker pipeline through SageMaker Studio using notebooks. So it helps. So if you have a regular model update requirement, right? So your data changes every month and you want to return your model in a monthly basis, then all you need is to create those rules to trigger the pipeline execution so that you don't need to have your data scientist, come back every month and just to refresh the model, right? So everything can be automated. And now you see a separate account, okay, so which is the production account. So the production account, you will see the SageMaker endpoint, where this is where your machine learning model is deployed. And the SageMaker endpoint can be accessed by end users through REST API. You can use AWS Lambda or Amazon API Gateway to access SageMaker endpoint. And now you see another account, which is called a staging account. So this is needed because we need to keep a quality gate control. So before putting any machine learning model into production, right? So you always want to stage it first. This staging account serves for that purpose, so that you make sure so your model is behaving in the expected manner, right? It doesn't broke. This is the staging account. It has the same configuration as the production account. And how to deploy those deployment? We mentioned earlier, right? So data scientist, so now I'm in the stage that, okay, I trained your model. Okay, you asked me to deploy in the staging account or the production account, how to do that. So here is the, how we integrate with AWS code pipeline. So this code pipeline can be triggered again by Amazon event bridge. And once triggered, it will deploy those staging account and the production account on your behalf, right? So you will see here, there is a trigger of this event bridge, which is a model approved. This means if once you register the model in model registry, you can have a model reviewer and to make sure everything looks fine. And then that model reviewer can approve this model, and this approval event will trigger code pipeline to deploy this approved model into staging account and the production account. So now you see the data capture part, where data is captured from SageMaker endpoint and stored in Amazon S3. It is used for model monitor purpose, right? So you have your model running in production, And now you need to collect some production data and the model's performance on your production data and compare this model's performance on production data with the baseline you set earlier. And so this is the how SageMaker Model Monitor works, right? So you can further use connect SageMaker Model Monitor with this event bridge component. You will see there is a drift trigger, right? So you can as I said, you can automate these steps. So so once you compare your model performance in production, drifted from your baseline, and you can use this event to trigger event bridge and to trigger the execution of SageMaker pipeline to return your model. Okay. Oops. Okay, really complicated, right? So okay. This there is some resources, and you can find after we share this slide. And now I'm going to do a fun part demo. I'm going to show you whether I'm talking is real, right? So you will see all I talked about this is SageMaker environment, so and this MLOps, so you can leverage it. That's a real thing. So now I'm in SageMaker Studio. So as I mentioned earlier, so it is web. It has a web interface, right? So I logged in through a URL through a web browser, and if you click on the left, so click this home, so you will see some scaffoldings, right? So it contains a lot of features. So today we are not going to spend a lot of time in SageMaker. So I think said earlier, so we encourage you to try it yourself. Okay, so still on the left, so you will find this deployment. Okay, so under this deployments, there is projects. So this project is SageMaker projects, right? So the third component we mentioned earlier for MLOps. If you click this projects, you will see. So okay, I've built multiple SageMaker projects, but today I'm going to create a new with you. If you click this create projects, you will see those templates. Okay, so those are the built-in templates I introduced earlier. Is it large enough? No, probably not, right? So let's make it larger. So okay, so the first template. So this one example is a template for model building and training, and you will also find a template for building, training, deployment, and monitoring. Or building, training, and deployment. So there is also template so with a third-party Git repository, because by default, so we integrate with AWS fully managed Git service called code commit. Okay. So, but you can also, use GitHub, or GitLab, with those third-party Git repositories. Anyhow, so now let's choose this template for model building, training, and deployment. Okay, so I click this select template, and I will give it a name, right? So, for example, MLOps July demo. And you can give it some description, but it's optional. And then you can click this create a project. Okay, so at the back end, it will fetch that CloudFormation template from a service catalog, and create the environment on your behalf. So it will take a few minutes. So let's revisit it later, because I have created a project beforehand, so we can use that one for demonstration purpose. Okay, so this is the one I built earlier. MLOps class made demo. So you click this project, you will find several tabs. Okay, so the first tab is repository. Okay, so this repository, it has a model build repo and model deploy repo. So you are able to clone those two repos through this link, and I've already cloned. Okay, so and here is the code. All right, so this is the model build, and here you see the notebook, right? So, and it prompts you to select a image, which is a container environment, right? So, and the kernel. So, a data science Python 3 is a commonly used configuration for running a basic notebook. And then it prompts you to select instance type. So this is important, right? So for this notebook, so I am going to leverage different containers, different environments for processing, for model building, for model evaluating. So I don't really need to, assign heavy resource, computing resource for this notebook environment, because this notebook environment, I'm only using it to running some commands, right? So I will just select a small instance, okay, and then you can select and it's a starting kernel so that you can run the commands. Okay, I'm not going to run the commands, but only use it for demonstration purposes. So you will see some scaffoldings here, and it tells you what is the built-in project template code structure. So you will see it has a pipeline, SageMaker pipelines code. It has some setup configurations, right? So okay, we will skip a lot of those. So see, here is if you can get this pipeline defined in that code repo, so you are able to execute. Remember what we introduced, how SageMaker pipelines work, right? So you created the steps, you created the definition, and then you execute the pipeline. So it's that simple, right? So this is the demo of how you can start the pipeline. But there are different ways to start the pipeline. You will see it later. Okay, before we jump to another way, so let me quickly go through the pipeline code here. So, and this pipeline, it is built using a use case classifying, predicting the age of a type of shellfish, which is abalone. Okay, so boring use case, but you get the idea. So, and in this code, this pipeline Python file, it defines the pipeline steps. Okay, let me jump to the end of the code here. You will see it has, let me make it larger. You will see all of the steps. So it contains the step process, which is the data processing. It contains the step train, which is the model training, and the step evaluation. Conditional. The last step is step conditional. It means so you can register your model on a condition that it meets the metrics predefined, right? And then you can find all of those code above. For example, this is the training step, right? So, and it utilizes XGBoost model, and this is the hyperparameters of the XGBoost model. Okay, so this is the pipeline code. Okay, so now let's see. So what is another way to trigger the pipeline execution? So, because earlier in this notebook, so we've seen that you can use a code, right? So this Python, using this Python SDK, pipeline start to start executing the pipeline, and you can also use sorry about that. You can also use the alternative way. So if you go to this projects again, so okay, so here the projects it open, right? So on the right tab, so you will see pipelines. So this is the pipelines created, okay? And if you double click, you will see this DAG, okay? And then this DAG, so it changes the step of ML workflow, right? It starts with pre-processing and training, evaluation, and this, checking whether it meets the, evaluation metric. So if it meets the metric, so register, right? So you will see each step. If you double click each step, so you will see on the right, it tells you the, what is the input of this step, what is the output of this step, what are the logs and additional informations, right? So, and the green means it runs successfully. But if it is red, then something went wrong, and you can double click and check the log and see, and to troubleshoot, right? So, yeah, this is, the DAG part. Okay, now let's double click this last step. Okay, so here you see, so this is your model, right? It tells you the MSE, so the mean squared error, right? For this model, it gives you this value, right? Okay, so this is the model pipeline, and you will see that we've been able to trigger a pipeline. So either in a Python SDK API call, or we can go to that DAG and to monitor each step, right? So, all right, do we have a time left? Anyone is catching a flight? So yeah, so there are let me wrap up in a minute, okay? So I'm going to quickly show you that one more thing. So because we are talking about the CI/CD, right? So we're talking about CI/CD. What does that mean? Earlier in the architectural graph, you see code pipeline. So in that code pipeline, so it is deploying the environment. So now I'm going to this code pipeline. So and see, you can see, so it is building that the project we just created earlier, right? So this MLOps July demo, and you see it is in the building stage. And here it gives you the link, so you can click the link. It brings you to our code build. So where the building logs and building steps are tracked, and then you can click and see all of those building logs to track the progress. If something went wrong, so you are also able to you're also able to find out where the error comes from, right? So this is the integration, the CI/CD integration part. So on the very left, okay, so last feature. So on the very left, you will see this code commit button. Okay, so you will see if you made certain changes, all of the changes are tracked here. So that means if you modify your hub parameter, you modify your processing code, so on and so forth. So you can commit these changes through without leaving the SageMaker Studio environment. Upon the code commit, so you will see a code build has been triggered, and that code build will update your new feature engineering code or new hyperparameter code, and to re-execute the SageMaker pipeline. So this is the my favorite part, because so it really shows the value of CI/CD, right? So one data scientist doesn't have to leave the development environment, and in order to push their changes and push a new model to be deployed later. All right, so sorry about running out of time. So yeah, this is pretty much about the demo. Any questions? Yes, please.
Yeah, I do have a question.
Can we go back to the slides? Before the demo, the slides. Before the demo. I want to understand your end results. Yeah, in this one. If your end results looks like is it deployed into all the scaling group? I assume it's a group of yes. So your end results is not deployed into like a full cluster, but is a group of yes. Is that correct?
Okay, so here is a SageMaker based ML ops workflow. So we utilize SageMaker to manage the endpoint. So and the endpoint here is yes, you're right. So you can treat it as a instance or a virtual machine. We call it a container. So it is usually a container in a specific instance. When we see auto scaling, so this is a managed auto scaling process. You can increase the number of containers or the number of instances.
It's not ECS.
It's not ECS.
Yes.
Not EKS. It is a SageMaker managed service. Not Kubeflow. Not Kubeflow. SageMaker MLOps.
And also this endpoint in front of it, if you see the tracking comes in from API gateway and then call lambda function, why that? I was saying if you expose the endpoint, they invoke traffic comes in through API gateway, it will directly hit your endpoint. Right? Why you need a lambda function in between?
That is a very great question. Actually, just I'm working on a blog that is going to be published soon. So which demonstrate you can trigger endpoint, SageMaker endpoint directly from API gateway. Okay, that is definitely doable. However, we put a lambda in the middle is because there might be some processing needed. So so the raw data comes through API gateway. And you may process the data, for example, converting as a format before sending it to SageMaker endpoint, right? So that's why we put a lambda. That's a typical, architecture. But you are right, as not necessarily, it's not has to be there, right? Not necessarily. So
your model is in Google's term. Usually the model registers into a container, registry. In your case, it seems like it's not that. But also in the middle of the picture, I saw you have an ECR, which is a container registry. That is for environment. Right?
For environment.
Yeah, so I'm not sure if your model really, the final format of the model is look like.
Right.
Docker image.
No. Right, so the model is a compressed file, so in GZ format, and we usually push it into S3 bucket, which is a storage service. And then upon deployment, so you will download that model into a container. So into a container for this endpoint environment. So download that model, unpack it, and deploy it in that environment. So the ECR here is mostly for the environment setup, you're right. So if, earlier you show in the notebook, right? So as like a data science, so there are various of containers, so built-in containers for you to choose from, but you can also bring your own container and use the ECR to register your own container so that, you can leverage your own container for model building purpose or data processing purpose.
So your answer is that the end model, does it go into an ECR container, which is like a Docker? First of all, the end model, is it a Docker image? Does it go into ECR container?
My endpoint will fetch that container and from ECR, but the model is stored in S3. So in the endpoint, it will first fetch the container. So using that container to set up the environment and then download the model deploy in this environment. Yeah, sure.
Something good, yeah, I don't have very same questions. When you server, when you on the model, you the server is
built by the site maker. You
SageMaker.
or SageMaker. And then the model is, so you must serve model as a multi-tenant, right? Multiple model maybe running at same server, use the same GPU, right?
It is one choice.
One choice just, it is, just each model running user one server.
Okay, so here is how it works, right? So for SageMaker endpoint, so it is a single instance, but it can host multiple containers, right? So there are 4 types of endpoint, right? One is a single instance, a single container, single model, and second is a single instance, single container, multiple model. For those models, they share the same architecture, share the same environment. And the third is the one instance, multiple container, and each container, it hosts one model. So this serves for model who have different architectures. So for both, single instance, single container, multiple model, and a single instance, multiple container, multi-model. So we use it to reduce your cost of hosting your model. And the last is multiple instance, multiple container, multiple model. So this is ideal for multivariate, for example, A/B testing purpose, right? So that if you want to switch from model A to model B, you can use SageMaker to seamlessly do the switch from one instance to the other instance, but in the same SageMaker endpoint.
But it's not multi-tenant. That's the question. Yeah. It's only for single tenant.
Single tenant. Single tenant. Yeah. So this account here, so this production account is your AWS account. So it is single tenant.
Yeah, but the single tenant will have bigger issue in the resource utilization because like you have so many users, so if they have so many users, so how do you handle this utilization? Because not every user always use all the users GPU resource, because currently GPU resource is more expensive than CPU.
Yes, exactly. That's why we have the second and the third, right? So the second, the same endpoint, you can host multiple models. We call it a multi-model endpoint.
Yeah.
And you can host up to thousands of models.
Yeah, but this have another issue is if one model suddenly have a huge throughput or huge input, that's will definitely infect another models because it has 1,000. This have another chance one model will be a noise neighbor or something, and it definitely influence another.
Correct, right? So for multi-model endpoint, so there is a model, upload. This model is when this model is loaded in the memory, other models not loaded.
Yeah.
Right. So you are absolutely right. Right. So then for the use case you are talking about, so the multi-container endpoint is the better choice because you can still manage the cost because it's still a single endpoint. But there is no model loading, unloading process, right? So you can use that single container so to handle, this heavy traffic. And also you can choose auto scaling to handle that, if there is a, spiky traffic. So
yeah, but the follow-up question is if you just unload model from the memory to actually for GPU, if we certain things, the input will cause the warm up, right? If we have warm up the issues. So how if you just unload the model out from memory and then if someone wants to use this model and then again the warm up issues happen.
You are spot on, right? So that's a ideal use case for our innovation on behalf of a customer. So SageMaker released warm start, so end of last year, so as a new feature. so that, this won't start can help you resolve that issue while you still can manage the
If
cost.
the memory
Right.
is fixed, you cannot hold every model inside the memory. Yeah.
Yes, correct, right? So that's why we, we needed to combine, so the, this multi-model, idea and, auto scaling. So, so to, address the issue you just mentioned, right? So another thing I didn't cover is serverless, right? So the serverless endpoint is you don't need to host and manage a instance by yourself, but use a fully managed service to handle a spiky traffic.
Yeah, but if you for scanning, you just scanning the container, they still need time actually.
It still takes
And
takes
also-
time, yes.
Also traffic, and also even for data center, you service unlimited. It's not a normal, not like say until you. Maybe everyone has some quarter. Once you hit this target. So this I think.
Okay, we can have more discussion offline. Yes, thanks a lot for the great questions. Right.
Definition of container is different from, usually when we say container is like a container it's like containerized, so it runs on ECS, KS, right? But container here, you have issues different. That's why I see it.
Yeah, it doesn't have to be EKS. So it's a container. Is
it a
Docker image?
It is.
Mhm.
It's probably AWS managed.
AWS managed, right?
You don't.
I'm going to ask them a different kind of question about process. So we're talking about unlock. So traditionally in the industry, we do not have unlock department. We have data science, we have data engineering, and we have DevOps. So what's the best practice here? If we want to kind of manage the release of the model, like the full life cycle of it, what do you think? Who should be accountable for the unlock process? That's the first question. The second question also related to the process, right? Because if we talk about the DevOps unlock, well, I consider unlock as an extension of the unlock. We have to talk about the release. We have to talk about the different environment of that, UAT, and production. So how we are going to handle that production data, and what's the best practice? Are we going to use production data in that? So two questions. First is a resource allocation. Who will be accountable? The second one is how to handle production in industry. Well, this is not related to the research and technology. What's from your point of view? What's the answer for those two questions?
Yeah. Thanks for the question. Let me first address your first question, right? So what is the role of data scientist? So what is the role of the MLOps engineer in this MLOps architecture, right? So if we come back to this architecture, so I would say data scientists are responsible for the model building part, and they are also responsible for which model to be approved and deployed in production. So, and MLOps engineer, however, so they are responsible of creating in this use case, for example, it is the CloudFormation template or Terraform template, right? So which defines the deployment process and the deployment environment. So this is how we see a typical, role associated with this MLOps process. So
it's a separate team.
Separate team. Right. That's why we also, we created this multiple AWS account for that purpose as well. So this deployment account is usually handled by data science team, while the production account and the staging account are handled by MLOps team, right? So Did that answer your first question?
Yeah, well, it's, we were, doing similar approach, but there's a lot of issues, so.
Okay.
That's not going to be covered, that usually data engineer, have difficulties to fully understand the data science or whatever. Data scientists is not interested about how the data was prepared, and also not interested about how it's published. So there is there's some conflicts, so we were trying to find out what's the best approach to merge them together. And that's why I asked you the question. Now, what about the second question about because traditionally the DevOps will handle about you go from the lower environment to the upper environment, right? So that's probably release. But if data scientists are working on test data, the model is useless. We need to work on the production data. So how to handle what's the industry best practice?
Yeah, so as I showed here, so you will see there's a data capture flow, right? So the data capture is done in the production environment in this staging account or this production account. This production account might be more relevant to the where production data is collected. Right. So when the data is captured and is stored in the S3 bucket for this particular account, and you will see there is another data replication. So data replication is replicating this S3, where the data captured and stored, and to the development account where data scientists, are hold accountable. So this is, with this data capturing, and this data capturing is actually both the production data itself and the model performance on the production data. And then this is the feedback loop, feeding the development account for data scientists to analyze. So
you that environment actually running with production data.
Mm-hmm.
And is there a process, kind of a building process to de-identify the data or mask the data, or this wrong with it because of that?